Hey everyone, welcome back to another tutorial. This tutorial is about vectors, C-frames, and raycasting. So we'll be using the position C-frame values, so look vector, and we'll utilize them to do some raycasting with parts. So to begin, I'm just going to explain a little bit of vectors and C-frames, and then we'll move on to raycasting, where we'll actually have it shoot a ray towards a certain direction, find whatever it hits. So yeah, so to begin, I'm going to use the surface modifiers to show which way is forward. So that would be this one right here. So that one's the forward direction. We have the left direction as the universal, and then we have the top direction as glue, or glue, yeah. There we go. So we have the forward, so that's the way the part's facing. We have the left, which is the left direction the part's facing. We have up, which is the up direction the part's facing. So these values are gathered in the coordinate frame, which are made up of vectors and, well, actually it's numbers, but it has a vector and a rotation matrix, which is a higher level of a topic called quaternions, but I won't explain any of that because it's bloody complicated and it's annoying. But what I will explain is how you can find the vectors and how you can use them to raycast. So first what I'm going to do is just make the part move along certain axes using vectors and then using C-frames, so you can see what the difference is. So to begin this, I'm just going to make a script. And in this script, I'm going to just make a variable part, which is script.parent. And we're going to have a look at the values that we can use. So we have the orientation, position, and then there's a C-frame one, which you can't actually see. I'm just going to make sure this is anchored, can incline to false. However, we want to move the position of the part along certain axes. So an example of this would be, let's do a loop, part.position plus, part.position equals part.position plus a vector 3. So vector 3s are x, y, z. So you will see them in the orientation, position, and velocity and rotation velocity. However, there's also vector 2, which is x and y values. So vector 2.new, you have x and y, and then you got a few other ones under here, which is x and y. So in here, we want to make it move along the x-axis by 1 stud. So that should be towards the left, I believe. So this stud direction. Nope, other way. Okay. So it's going along the stud there. And then if we make that -1, it should go towards the left direction now. And then if we put it against a negative z-axis, it should be going forward, like so. And then if we have it a positive 1 in the y-axis, it should be going upwards, like so. Let me also... So that's directional vectors, so it's saying add this certain number to each of the x, y, z position values, and then that should move it towards whatever direction it's going towards. So with this here, this is a direction vector of 1, so magnitude of 1. This is a unit vector. So unit vectors have a value of 1, but they point towards a certain direction. So you can actually multiply this by like another value to make it like travel a larger distance towards that direction. So right here, it's moving 3 studs up instead of 1. Yes, you could do this. But if I do something like this, And then let's do 2 stud movement. You'll see it starts going on this diagonal path in the 3D world. Now, you could say, oh yeah, you can just, set that to 2, and all that's good. However, once you use look vectors and all that, it's just easier to multiply it, because you just do part.cFrame.look vector times by 5. So the look vector is a unit vector, as it's pointing in a certain direction. So that would be where this yellow thing is poking out. It'll be pointing in that direction, and we just want to move in that direction by 5 studs. So I'll make it 3 studs so it doesn't jump super far. But yeah, let me just run that, and you'll see it jumps towards whatever way it's looking. So if I turn it that way, it will start going that way. And this won't work if you have it as a vector. So like you add your own vector to it. So if I do that, it will always move right, even if I rotate it, as you can see. So CFrames take into consideration the orientation, which is important. So if we just change this back to part.cFrame.lookVector times by 2. So that's saying just add to the position whatever way the part's looking at by 2 studs. Now there's also another one which is up vector, and that's the up direction of the object, which is that way. So if I flip it that way, that's the up direction now, so it's coming towards here, going towards there. That's the up one there. There we go. Let me put it back up. And this can work for the right vector too. So the stud here. Oh no, wait. Did I put this in the wrong face? Oh, I did. That's the left surface. On the right surface, we want the universal. Like that. So now it's going towards the right direction. And if I rotate again, it utilizes the orientation of the part, and it will update the direction that it goes. Next is how we can actually use these vectors here to get the opposite direction. So right now it's going the right vector, but what if I want the left? Well, if you multiply it by a negative number, it will flip the direction, like so. So instead of going right, it's going left. So it inverses all the signs of the direction vector. So x, y, z, the x, if it's a positive, it'll become negative. If it's negative, it'll become positive. And it will do that for each x, y, z. And yeah, that's just the nature of how that works. Alright, next we'll do a little bit of raycasting now. So I'm going to set up something else here. I'm going to set this back to smooth. So the left, right, and top, I'm going to set them to smooth. I do want to keep the hinge though, because this is the direction we'll have the ray fire out. So if I put attachment 0 and attachment 1, and I just pull this one out. Here we go. So we have the start of the ray. Oh, the start of the ray is where the part is. And then the finish of the ray is this part here. However, if I make a beam, we can actually visualize this considerably easier. There we go. Like that. So you have the start of it, and then you got the end of it. So let's say there's a part in the way here. We want this end beam to raycast out and stop wherever this part actually hits the ray. And then like this will move around, it'll still be in the same spot. if this moves around, it will still be in the same spot. I can't really visualize it unless I script it, but yeah. And then let's say it goes way back here. If it's out of range, we'll just have it go to where the max range is, so we know. And then it'll hit it and then slowly come back. So to do this, I'm going to set this up as ray part. And I'm going to actually grab another part for the normal of the raycast result. So the normal of a normal vector is the forward direction of the surface. So if it's raycasting this way and hits the surface, if it's rotated like this, the normal will give us the rotation. So that a part that's using the normal vector will look like this. So it will stick out of the part on the surface's orientation. So that ray will come in, we'll have this block rotate like this. So we know that's angled the surface. So to do this, I'm going to change it to that. Actually, I might need to make it smaller. Like this. So this little part will show the normal of the surface. So we'll call this one the normal. Actually, I'll call it the normal part. And we've got the array part. And then we'll have like other objects that we can mess around with. Alright, so what we do now, you can like put this in a model or whatever you want. I'm just going to put this as a model. You can put your script in here. I'm going to put this as array handler. And then we can just begin with getting our variables together. So local normal part equals script.parent.normal part. Local ray part equals script.parent.ray part. And then we need to do a few things. So what we need to do first is have a look at what raycast requires. So workspace : raycast. We need a origin. We need a direction, so such as log vector. And we need raycast params, which we'll make. So to start this off, workspace : raycast, we want the raypart.position. And then we want the raypart.cframe.log vector times by 20. So that's the array length. Let's make that a variable. Max array length. So that will get us a actually we need the params too. So in the params there can be a blacklist. So we want to use this blacklist and make sure these parts here aren't detected within the array. So the part here and this other part, the attachments won't do anything. So local ray params equals raycast params.new. Ray params dot filter type equals enum dot raycast filter type dot blacklist. Ray params dot filter descendant instances equals a table, and we want the ray part and the normal part in there. So it will detect anything except the ray part and normal part. You can also make ignore water true. So if you're using terrain water, you can make ignore it. And you want this as the third argument. So now that we've called it, we actually need to get the result that we get. So the result is a raycast result, and that has a few pieces of information inside it. So in the wiki, it has raycast result. It has a instance, it has a position, it has a normal, and it has a material. So if it hits something, all of these will be available. If it doesn't hit anything, none of these will be available. So And if you want light to position where the array ends, what you have to do is this array position plus the look vector times array length. So that's the end position. So this is, if it goes through all objects, this is where it would end at. So you can use that for whatever you need, but we're using the raycast result here. So if result, then we want to move the array part. Oh wait, we want the array part dot attachment 1. So the one sticking out. We want that world position to be where the array hit. So result.position. So this is where the array actually hit the objects. And then we want the hit normal, or the normal part, I mean. We want that CFrame to be CFrame.new, the resultant position, and we want it to look towards the resultant position plus the array part, or the result.normal. So this way, you have the position of the part where at whatever point on this. The normal is the direction vector pointing outwards from the rotated part. So when you add the normal to the position, it will move it forward a little bit. And when you make a C-frame, it will be at where the raycast hit, facing towards the raycast plus normal point. So actually I can show you in Paint. Oh, let's Paint.net. Oh well. So let's say you have your wall here. So you have your hit point, which is, let's say, right here. So this is where the ray hit. You have a normal vector pointing in this direction. This is the incoming array. So you have your normal, which is perpendicular to the surface, so it's on a right angle. Oh god, that's wanted. Hold on. There we go. So it's on a right angle to the surface. So it's going straight out the surface. So you get that hit position, you plus the unit vector, and it moves slightly forward. So let's say right there. Well, actually be way closer, but it'll move. So we'll get another one point right there. So we want to put a C-frame. This as the origin, looking at this one right here. So this is the direction the C-frame would face. So the log vector would be pointing this way, where the normal is. And when we set the normal part C-frame, it will actually rotate it facing the way out, which is what we want. I think I over-explained that, but it's fine. So what we're going to do next is array part. So if there is no raycast result, we just want to do this. So this is where it hit. So it pretty much missed everything. So we'll just show where the max distance of the ray is. So max ray length. And then the hit normal dot CFrame equals CFrame.new the other part's position. Now if we try this, actually I should really have it outside more. There we go. So I can actually move this part and then this part moves on its own. So if we move this out here, you can see where the max thing is. And we just move it closer. What happened? Let me have a look. Oh, that's right, yeah. So we actually need to loop this. So it's only running once. What I'm going to do is while wait do end. So this whole thing is inside a loop that goes, I think, 1/30th of a second. It will update that often. So if we try now, As we move it, there we go. We get our raycast result. So that's what I mean by max distance. It actually doesn't keep going, it will stop there. However, if we move closer, it'll keep track there. So we have our normal vector here. So if I just rotate this slightly, not that way, this way, you'll notice that the part on here rotates facing with the surface, which is what I wanted. And yeah, that's the raycasting part done. So if you want to fix that, make sure the can collide's false, which I did not do for this normal part. So if I try this again, it won't work. There we go. And yeah, we can actually use this to detect players too. So if I just reset this, make sure that's false. And I just jumped in with my character. So if I start moving it this way, you'll see it hits my leg. It follows the normal of my leg, so even with the animations playing, it will still correct it. Like that. So you see it moves with the body. And yeah, there we go. And it can detect accessories too, like that. Although the bounding box is a little bit big, but that's fine. And yeah, if I move out the way, it will fire off that way. Haha. But yeah, hopefully that helped you understand raycasting, C-frames, and vectors a little bit more. Let me know if you want anything else. I'm trying to avoid from complex math, like oh my god, people have been asking me to do marching cubes. I don't want to do that again. That was way too much. But I might do it. We'll see. We'll see how that goes. But yeah. It would have to wait a bit though, because it's a little bit complicated, and this is only the basic stuff. But yeah, hopefully that helped you out, and let me know what else you want in the comments. I do check them. You can check all past videos. I have commented very often. But hope you enjoy your day.